Hello. So today we're gonna do a differential equation problem, which is something that I thought is new on the analysis and approach syllabus, but I found a question from May 2005, TZ1 Paper 2, higher level. Okay, so I was mistaken. Maybe it's always been there. We just never knew. Anyway, so this is the question which asks you to solve the differential equation, and it looks very horrific, I would say. Cosine squared x divided by y, e of y minus e to the power of e to the power of y dy dx equals to 0. And then it gives us some initial conditions, which is y is equal to 0 when x is equal to pi. Okay, so this kind of question, I'm sorry, I'm afraid that there isn't much of a story behind it, unlike complex numbers. For differential equations, all you gotta do is try to separate the variables. By that I mean, for example, when you see dy and dx, you try to separate dy and dx onto two parts of the equation, two sides of the equation, and then you try to solve by integrating both sides at the same time. Okay, so let me rewrite this. Okay, so solving a differential equation. All right. Okay, so basically, there are two things you have to do. Okay, two things you have to keep in mind. First of all, try to put dy and dx on two different sides. Dy on one side, dx on the other side. Okay. So we call this a separable equation, right? We could do that. And then two, we try to write y. When they say try solve the differential equation, basically we want the equation to be of the form y equals to da 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 da. Okay. Find y equals to let's say an equation where left hand side is strictly just y, right hand side is just x, right? So we want some sort of let's say function of x, right? How can I write this so that it's more clear? Because typically it's gonna be logarithmic or exponential. Let's say logarithmic or exponential. But that could be tricky. Well, you know what? Let's just leave it like that, and if we need to fix it, we fix it later, alright? Exponential function of x or otherwise. Clever me. So now, basically, the goal, okay, what I want to emphasize here is you try to express the equation as y equals to something. That's your ultimate goal, because there are so many steps in solving a differential equation. If you're lucky, if you get a separable exact equation, then you don't need any integrating factor. But then if you got an equation where you would need an integrating factor, then you've got multiple steps in solving it, and then you got to integrate both sides at the same time, and then you still have to figure out the constant. So it's very complicated, so you got to keep this goal in mind, right? So your ultimate goal is to express y in terms of x, right? I.e. so, or otherwise, which is to say express y in terms of x. Okay, so this is our goal when we're trying to solve a differential equation, right? And I think that's reasonable because ultimately what we want to do, maybe we want to sketch the graph a little bit, understand the behavior a little bit, and without seeing any dy dx in our equation. Okay, so this is our goal when we're trying to do a differential equation. Okay, so for this particular question, let me create some space down here. All right, let me copy the question. Okay, so we have a better idea of what it's doing, maybe. So we've got cosine square x divided by e to the power of y minus e to the power of e y dy dx equals to 0. Okay, so what we've got to do first is to recognize something. Okay, so when you're let me take this away for a while. Okay, so when you're trying to solve this, when I first solved this, I was completely mistaken. I took this whole thing to be together, which is wrong. You gotta have this, right? You gotta have the brackets so that you know the dy and dx is quote unquote attached to this part only and not to this other part. Which is to say, when you rewrite this equation, it's gonna look like this. Okay, so the dy and dx stays here, and the cosine square x divided by ey goes to the other side, right? So it's not attached to everything. If it's attached, it would be it would have the whole two brackets around. All right, so then what else can we do? Well, we can multiply both sides by ey and by -1, right? So we would have e to the power of ey, right, times ey. And remember, well, you can add brackets to make it more safe if you want, but it's not necessary. But anything that makes it more clear, I think it's gonna be helpful. All right. So let me write the note here. Okay, so note. This is not the same. Okay, not the same as cosine square x ey minus ey dy dx equals to 0. All right. If it were this, you would be in big trouble, because try separating dy and dx into two places. You would get something horribly complicated on one side, and then you would get dx on the other side, and like it's at this stage, I don't think you can solve it that way. Okay, so you got to remember where this dy dx is attached to. Okay, coming back to our original equation, what can we do next? We can multiply both sides, quote unquote, by by dx, right? Equals to cosine square x dx. So now that looks much better, because we've got one variable on one side and another variable on the other side, and so everything has been neatly separated into onto two sides of the equation, right? So then we gotta integrate both sides together. So let me move this a little bit up here if possible. All right, so we gotta integrate both sides together to get what we want. Okay, dy equals to this. Okay. All right, so I don't know which part is easier. I would say the left-hand side is a little bit easier to integrate, because I think a natural reflex response is to use substitution. Okay, in this case, let's say, so let u equals to e to the power of y, then du equals to ey dy. Okay, so that looks pretty neat for us, because then in our original equation, we've already got our okay, so we've already got our du up here, right? So I could say, therefore, that integration of e, okay, instead of ey over here, we've got, let me rewrite it again, right? Times ey dy would be here. This is our u, right? U is equal to ey, and then we plug it back here, and this is just our du. EU, and then DU, right? That's cool, which is to say that we can just integrate this directly, and that comes out to be EU, right? Of course, plus C, all right, if we want, but we can deal with that later, okay? And this is just equal to EY, okay? So on the left-hand side, we've come up with this as our final integral, final solution for our integration. On the right-hand side, what can we do? We have to recall our fabulous identity, don't we? So if you do take a look at your equation book, what is it called? Data booklet. You can find the identity here, because whenever we see any square of cosine or sine, we gotta change it into a double angle because it's much easier to deal with that. Okay, so remember, we have to say it's recall identity. Recall identity, we got what? 2 cosine square x equals to cosine of 2x plus 1. Okay. Actually, I think I'm mistaken. I think the identity, it should be 2 cosine square x plus 1 equals to cosine 2x, all right? So that's the identity. That's one of the transformations for our cosine 2x. So we want to express cosine of square x in terms of the double angle identity. Therefore, cosine square x equals to cosine 2x minus 1 divided by 2. I think I'm horribly mistaken about the identity because I never memorized this kind of identity. So I think it's minus 1 instead of 1 over here. And it should be, my bad. So this one should be minus 1. Okay, let's wait for it to dry and I'll fill it back in. But so on the right hand side, what we're integrating, instead of cosine square x dx, we're integrating this identity here. Okay, plus 1 dx. All right, is it dry yet? Let me see. Right, vaguely dry. Anyway, so we've got this identity here, and that does a lot of good because now it's much easier to integrate. Okay, so we move the 1/2 outside and we get this one. And then what is our integration of cosine 2x? First of all, you've got to remember there's a reverse chain rule, right? Before, if you were gonna derive cosine 2x, you would produce a 2x. You would produce a 2 outside. Therefore, when you're doing the integration, you've got to do the reciprocal of your 2, which is 1 over 2, and you gotta have sine 2x. And here we've got x, right? So basically, we got left-hand side is this, right-hand side is this. And now you've got to remember that there is this initial condition which is given, and which is the hint for our constant, right? So our constant, okay, it's gonna be something like this, right? I suppose that's reasonable, right? And so let me summarize this. Okay, let's proceed to another piece of paper. Maybe I can keep this here. All right, so what we have so far is this. Okay, we're not done yet because, as I said, okay, let's see what our goal is. Okay, we've done the first step, dy on one side, dx on the other side. Great. But our goal is to express the whole thing in terms of y, and we're not done yet. So what we've got now is e to the power of ey is equal to 1/2 sine 2x plus x, and then plus c, right? So let us simplify this a little bit. 1/4. Okay, so I don't need this anymore. I put this over here. 1/4 sine 2x plus x over 2 plus c over 2, but it's just a constant, so we can just treat it as another c, right? Oh my god, it's still ugly looking. So how can we get rid of the whole thing and have y on one side? We're almost there. We could just take logarithm first, right? So let me write an extra step if that helps. Okay, so it's gonna be log of our 1/4 sine of 2x plus x over 2 plus c, and here our ey comes out, so we have ey equals to this, right? Sine 2x plus x over 2 plus c, and then we take our logarithm another time. This time we will get ln of ln 1/4 sine 2x plus x over 2 plus c. Alright, so we have two things, okay? Now, I have to admit this is one of the ugliest things I've ever seen. But now we're done, so we've accomplished what we've wanted to accomplish, right? We have, what do? We found y in terms of x, right? We've expressed y in terms of x. So that's pretty cool. So up to this point, you probably have 6 points already. It's out of 7, isn't it? So let's take a look at what the question says. Now, given that y is equal to 0 when x is equal to pi, let's see what we can do. All right. So when y is equal to 0, x is equal to, actually the reverse. Okay, y is equal to 0 when x is equal to pi. Right? So let's just plug these in so that we can figure out c. So we've got 0 equals to ln of ln and then 1/4 sine 2x, so 2 pi plus pi over 2 and plus c. Now that's interesting. First of all, let's see what we can do with the sine 2 pi. Sine 2 pi evidently is what is it? It's 0. So that's neatly gone. This is 0. So we want something like 0 is equal to ln of pi over 2 plus c, right? This is what we have. Now we have to consider, now that's the interesting part, because now we have to consider when is this thing going to be 0. This thing is going to be 0 when, let's use a cute color, yeah. When this box is going to be 1, isn't it? Because when 0, let's put it on the side, okay? When 0 is ln equals to y, for example, it means that it means what? It means e to the power of 0 is going to be 1. So y is going to be 1. Okay? So no matter what your base is actually, right? You could have 0 equals to, I don't know, log base 2 of q or something. Then 2 to the power of 0 is going to be q, and so q is still going to be 1, right? So basically this part is going to be 1. So this is to say that ln of pi over 2 plus c has to be 1, all right? So this is our idea of logarithm. Okay, no, not idea, it's a knowledge of logarithm. All right, then the other question is, what does this mean then? It means that this is logarithm of base e, which means that e to the power of 1, right, which is to say e to the power of 1 is pi over 2 plus c, right? Agreed? No? So based on the same logic of logarithm here, right? So we have basically c is equal to e minus pi over 2. So you really gotta review a little bit your logarithm, okay, to really get this part a little bit, right? Because the definition of logarithm in general is log base b of a equals to x implies, in fact, it's defined by the fact that b to the power of x is equal to a. Therefore, in our special case, we've got log base e of a is equal to x, right? Which is our ln, okay? Which is the same as saying that ln of a is x. It means that e to the power of x is a, right? It's the same case. Okay, no matter what your base is, you can change it into e, and then if it's e, we have a special thing for it. It's called ln. All right, so c is equal to this. So finally, we've got the what is it called? This final solution that we got. So have to plug it all in. Therefore, y is equal to ln 1/4 sine 2x plus 2 plus our c, which we know is this, e minus pi over 2, right? So that's our final solution. So this is our answer. All right. What a long journey, and we don't even have any explanation or whatever. We're just doing some motions. And then part B, what does it say? All right. Part B, find the value of y when x is equals to pi over 2. Right? So when x is equal to pi over 2, what a boring question, I must say. So we just plug it in. Ln 1/4. When x is equal to pi over 2, 2x is going to be what? Pi, right? So this is just pi plus pi over 2 divided by 2, pi over 4, plus the same old constant. And this sign of pi, of course, is 0, so we've got ln of ln and e minus pi over 2 plus pi over 4. Damn it, what kind of math is this? This is paper 2, so you can use the calculator. I suppose it's gonna be ln of e minus pi over 2 plus, okay, minus pi over 4, isn't it? I suppose that's right. All right, so that is the answer. All right. I think that's it. There's nothing special about this whole thing. But I do think, okay, we could check the value of this if we want. I haven't done it yet. Let's check the value. But I think it's good enough if we just leave it like that. So, but nonetheless, I'm curious what the value is. Ln of e minus pi over, sorry, I'm using a computer calculator, something like that. Okay, so the value turns out to be negative 0. Okay, so 1.7. All right, so either of these will give you full marks. All right. Oh, damn it. It's such a boring question. I'm sorry, but I don't like this kind of question. But we're done. So this is our paper 2 of May 2009. How about I write the solutions nicely on the board and everyone can see? Sine of 2x plus x plus over 2 plus e minus, oh my god, so neat. What am I doing? That's your answer, obviously. And then y equals to negative 417. Done. So that's it for today. I can't believe I spent another 25 minutes on this question, and it's not even as fun as the complex number question. So that's okay. We are not supposed to compare questions like that. I hope you have a wonderful weekend or weekday or work day, whatever. And that's it.